is also fine. Absolutely. So should I share my screen?
Yes, you can share your screen. I will just do the introduction after 2 p.m. So I think people will just be coming after the lunch. So I just wanted to check about this. So you have this memorial gold medal. Is that Lieutenant Rashi Roy? Is that how I should pronounce it?
Yes.
Okay. Okay. Sarth, do we have all the students back? All the participants back? Sarth, who is the TA? Are the students back in the room?
Yes, sir. They are back here. Yeah, in the room.
Okay. Should we get started?
Yes, sir.
Okay. So let us welcome Dr. Shriparna Saha. She received her MTech and PhD degrees in CS from ISI Kolkata in 2005 and 2011 respectively. She's currently an associate professor in CS department at IIT Patna. She's the author of a book published by Springer Verlag. She's authored or co-authored more than 290 papers. She's working on deep learning, NLP, machine learning, information extraction, text mining, bioinformatics, and multi-objective optimization. Her H-index is 30 and papers have been cited more than 5,000 times. She's a senior IEEE member and the recipient of Lieutenant Rashi Roy Memorial Gold Medal from ISI for outstanding performance during her master's. She's a recipient of Golden Google India Women in Engineering Award, NASI Young Scientist Platinum Jubilee Award, Bird Award, IE Young Engineers Award, Serve Women in Excellence Award, and Serve Early Career Research Award. She's also recipient of the Duo Indo Fellowship and Humboldt Research Fellowship, Indo-US Fellowship for Women in STEM. She received the India for EU Fellowship, and she's also the recipient of Erasmus Mundus Mobility and Asia Fellowship. So we welcome Shriparna and we look forward to her talk.
Yeah, thank you, Nipun, for this introduction, and thanks, Anirban, for inviting me in this ACM summer school. So yeah, sorry, I have actually initially there was a plan to be physically present there, but because of some family issues, it was not possible for me to travel. I am extremely sorry I could not meet you in person. But I will try to cover, today there is a lecture and tomorrow I have 2 other lectures. So I will give you introduction of some of the recent techniques in natural language processing. So in recent years, my research areas are natural language processing, text mining, and applications of machine learning and deep learnings in natural language processing. So basically, I am working on summarization systems and then dialogue systems as well. So in today's talk, I will basically mainly talk about the summarization systems. I will show you how basically we can apply some recent, the optimization techniques for solving the summarization problems. So basically today's talk will focus on that, and initially we will start with the text summarization systems, but gradually we will also go towards the multimodal summarization, because nowadays multimodal summarization is very common. So multimodal summarization means we have to summarize not only a set of text, but a set of text, a set of images, and also a set of videos, and then we need to generate multimodal summary as well. So the multimodal summary will have a text summary, a image summary, and also a video summary. So let me just try to introduce the problem statement. So, let me start with the concept of optimization, because I will show you that summarization is an example of optimization problem. So in summarization, there are two types of summarization. One is called the extractive, and another is called the abstractive. So in case of extractive, the task is to select a subset of sentences from the original document. So if your original document is having 1000 number of sentences, our task is to select carefully maybe 10 or 15 important sentences to generate the summary. And in the process, we need to basically optimize several objective functions. So let me just start with the introduction of optimization technique. So, optimization means we have to optimize either one or two or multiple objective functions. So if you are optimizing a single objective function, then this is called a single objective optimization. For example, suppose there is a card and you want to basically minimize the cost of the card. You want to buy the particular card whose cost is the minimum. Then this is an example of a single objective optimization. But if you have multiple objective functions like cost and comfort, so you want to minimize cost and you also want to maximize comfort, then cost and comfort are two conflicting objective functions. So it is not possible to minimize cost and maximize comfort at the same time, because these two are completely conflicting to each other. And if you are trying to minimize cost, comfort will be compromised, and if you want to maximize comfort, cost will also go high. So these are examples of conflicting objective functions. And if you are optimizing multiple conflicting objective functions, then this is called multi-objective optimization. So if we are optimizing multiple objective functions, then we are getting, basically in that case, this is called the multi-objective optimization. And in case of multi-objective optimization, it's very difficult to get a single solution. Rather, we can get a set of solutions which are called the non-dominated set. Okay, so like for example, you can see the cost and the safety. We are maximizing the safety and we are minimizing the cost. And in the process, we are getting not only single optimal solutions, but we are getting a set of non-dominated solutions, and this is called the Pareto optimal surface. For example, if you compare solution 1 and solution 2, solution 1 is better with respect to safety, but solution 2 is better with respect to cost, because solution 1 safety is higher compared to solution 2, but solution 2's cost is lower compared to solution 1. So solution 1 and solution 2 are non-dominated to each other, because we cannot say solution 1 dominates solution 2 or solution 2 dominates solution 1. So these two solutions called non-dominated solutions. And the set of all these non-dominated solutions is basically called the Pareto optimal surface. So in case of multi-objective optimization, our objective is to find a set of non-dominated solutions, and this set of non-dominated solutions basically constitute the Pareto optimal surface. And now, depending on the requirement, user can select a single solution from this Pareto optimal surface. Like if suppose the safety is more important, then he or she will select solution 1. But if suppose the cost is more important, then maybe the user will go for solution 3. So this is basically called the multi-objective optimization problem. And there is a, that at the end of any, after application of any multi-objective optimization approach, we are getting a set of solutions on the Pareto optimal surface. And then there is the user has to select a single solution from this Pareto optimal curve. So this is the formal definition of multi-objective optimization, that we have to simultaneously, there is a set of decision variables, and we have to satisfy some inequality constants and the equality constants, and also have to simultaneously optimize some objective functions. So you know that, for example, in case of purchasing a car, the objective functions could be, here, for example, cost, comfort, the number of, basically the weight of the card. These are the basically different objective functions, and then we can have different constants like number of seats in the car should be greater than or equal to 6, or the mileage of the car should be greater than or equal to 20 kilometer per liter. So these are the different constants. So basically we have to incorporate the many constants as well, and this is basically called the constant multi-objective optimization problem, where there are multiple objective functions. We need to simultaneously optimize these objective functions, and we have to satisfy some constants, and our target is to find out some decision variables. So there is no concept of global optima, but rather we are getting a set of parallel trade-off solutions, and this set of trade-off solutions is basically called the parallel optimal set. And already I discussed about this, and our task is to select a single solution from the parallel optimal set. So for example, here you can see that there are two objective functions, f1 and f2, and suppose we are maximizing both the objective functions. Now, if you compare solution 1 and solution 2, solution 1 is better with respect to f2, but solution 2 is better with respect to f1. So we cannot say solution 1 dominates solution 2 or solution 2 dominates solution 1. So these two solutions are called non-dominated solutions. And the set of this solution 1, solution 2, solution 3, and solution 4 are basically, set of non-dominated solutions, and they basically form the parallel surface. But now if you say solution 5, then you can see if you compare solution 2 and solution 5. So for both the objective functions, solution 5 is dominated by solution 2. So you can see that for both the objective functions, solution 2 is better than solution 5. So basically solution 5 is dominated by solution 2. So you can see, so 5 is dominated by 2, 3, and 4, but not by 1. Because if you see solution 1 and solution 5, so solution 1 is better with respect to F2, but solution 5 is better with respect to F1. So we cannot say solution 1 dominates solution 5 or solution 5 dominates solution 1. So these two solutions are called non-dominated to each other. So now let me discuss about our problem statement today. So today we will be discussing about the summarization problem. So this is a very important and interesting problem statement of natural language processing. So natural language processing means you need to deal with the text. So there is some documents or the text written in natural languages, and you need to basically somehow deal with this natural language text. So summarization is basically a kind of tool of natural language processing, where our task is to automatically create a compressed version of the text document. So this text document means either a set of tweets or a set of web pages, or it could be a single document or the multiple document. And then we need to generate a summary out of this. So this summary could be concise, relevant, non-redundant, and representative of the main idea of the text. So basically, either we can have mostly, suppose there is an event has happened, suppose some event has happened, and there are several newspapers who are reporting about the event. So we have all the news items. Now nobody is having time to go through all the news. So can we generate a summary? So the theme remains same. There is an individual event, and that event is basically covered in multiple news reports. And now we want to generate a summary so that the summary can contain the relevant information of the particular event. So this summary should be concise, relevant, non-redundant, and representative of the main idea of the text. So a text that is produced from one or more text that conveys important information in the original text, and that is no longer than half of the original text, and usually significantly less than that. So basically you can see this summary. Summary is basically a kind of a concise, relevant, non-redundant, and representative of the main idea of the text. So this summary contains all the important information which is available in the documents, and the summary is no longer than the half of the original text, and usually significantly less than that. So now why summarization? So because in the internet we have many documents. So in the internet, we have many documents, and obviously nobody is having time to go through all the documents. So rather, we can generate a summary so that users can easily get information about the relevant content. So the automatic text summarization systems are very much needed, because nowadays nobody is having enough time to go through the all the documents. So basically, we need to somehow compress the information, and we need to somehow make generate a compressed version of the information by covering the relevant information available in the documents. So now this summarization is having many real life applications or the implications. Like, it helps us in saving time, because as I mentioned, that now you do not have to go through all the documents. You are getting a compressed version of the compressed information, so as a form of the summary. So that way we can obviously save some time. Then it will help you in compressing the large information. So there are multiple documents, and the information is spread in multiple documents. So basically, summarization systems will help in compressing the large information. It will help in active reading, because now we can easily get the basic idea present in these multiple documents. It will easy to implement you know that summarization system. So basically, if you have the summary, then you can easily understand the current situation, and then accordingly some decisions can easily be taken. For example, suppose there is a disaster, and during the disaster, the physical connectivity is mostly lost. So people used to connect to each other through social media platforms. They used to update about their current status in the social media platforms like Facebook, Twitter, Instagram, etc. So maybe what we can do, we can collect those information, the tweets which people are doing during a disaster situation, and then we can basically categorize these tweets into two categories: relevant and non-relevant. So in amongst those tweets, there will be some tweets which only contain some sentiment and emotional information, and there will be some tweets which will contain some relevant information. So we need to categorize the tweets into two categories, basically relevant and non-relevant. Then basically non-relevant tweets can be discarded, and the relevant or the informative tweets can be identified, and then we can develop a summarization system which can somehow summarize this relevant or the informative tweets, and can generate can extract the useful information from those informative tweets. And then this summary can be easily given to the rescue team, and the rescue team can easily plan for the rescue operations, because from the tweets, if we can get the exact location where the people are stuck, and how many people are stuck, and how many people are injured, all this information, if we can easily extract from these tweets, then basically now the rescue team can easily focus on the summary, and can easily take a plan for some rescue operations accordingly. So basically, this helps us in decision making, and also it helps in highlighting the central theme, because as you know that summarization helps in highlighting the central theme, because now the central central theme will be basically the highlighted. You do not have to go through the entire document. In the summary, you will basically get all the relevant information. So these are the overall goals of the summarization systems, and it has many, it can help us in solving many real life problems. So in general, summarization is of two types. One is called the extractive summarization, and the other is called the abstractive summarization. So extractive, from the name itself, you can easily understand that suppose in the original document we have 1000 number of sentences, and now we only want to select the important sentences from the original document, and then we want to generate a summary. So basically, in the summary, we only want to keep those sentences which are informative, and which also contain the theme of the original document. So basically, that we are selecting few relevant sentences from the original document, and the relevance of sentences is decided using sentence coding features like sentence position, similarity with the title, etc. So originally, suppose in the document we have a set of sentences, and now we are extracting the important sentences, and then those important sentences are forming the summary. So how to select the important sentences? This is a kind of optimization problem, because we have, it is a basically subset selection problem. So we have a large collection of sentences. From this large collection, we need to extract some important sentences to generate the summary. So this is very much similar to a subset selection problem. And in order to select the important sentences, there are many objective functions, like the sentence position, similarity of the sentence with the title, then the information content of the particular sentence. So all these objective functions, there are multiple objective functions, and some of these objective functions are also conflicting in nature, and we need to simultaneously optimize all these objective functions, simultaneously select the important sentences to generate the summary. And now there is another concept called the abstractive summary. In case of abstractive summary, it's basically natural language generation. So basically here, somehow you have to combine the original set of sentences. You have to make some paraphrasing of the original set of sentences. And by returning the original, the actual information, we need to regenerate some new sentences. So this is very much similar to natural. Basically, this is called the natural language generation. Here we have to generate some new sentences focusing on the original set of sentences. So you know that in the abstract summary, which includes words and phrases which are not exactly similar to which are present in the original source document. So the actual, in the summary, we are generating some new sentences which are similar in content or in semantically or information wise. Those are very much similar to which are there in the original document, but there is a paraphrasing, or there is a, we are somehow merging two sentences, or we are paraphrasing the sentences. So we are basically rewriting the sentences. So this is very much equivalent to natural language generation or the reconstruction of sentences. So here you can see one example of this. So if suppose this is the original document, now we are basically selecting the colored sentences. So this we are selecting this blue, purple, all these colored sentences are selected, and then we are generating the extractive summary. Similarly, there is an abstractive summary. So you can see here, this is the original document, and now we are generating some new sentences. So these new sentences are paraphrased version of the original set of sentences, and this is basically called the abstractive summary. So now there are applications of summarization. There are different types of summarization techniques available. So one is called the query focus summarization. For example, suppose there is a query Taj Mahal. So you are searching with this query Taj Mahal, and as a result of that, you are getting many documents which are referring to basically which are talking about Taj Mahal. So now can we generate a summary of all these documents? So this is called the query focus summarization. So given a query, we are retrieving many documents, and now we are generating a summary out of those documents, and this is called the query focus summarization. If we are summarizing a single document, then this is called the single document summarization. If you are summarizing multiple documents together, then that is called the multi-document summarization. Then there is a concept called the figurative summarization. So suppose in a scientific document, there is a figure, and figure captions are very brief, and it's very difficult to understand with the help of the caption, it's very difficult to explain the figure. So but maybe the figure is described in text. So when suppose you are writing the scientific documents, especially in the biomedical articles, figures play a very important role, because researchers used to demonstrate some concept by using the figures. But the figure captions are very brief. So by seeing the figure caption, you will not be able to understand the figure fully. But in the text, researchers are describing the important components of the figure, or they are basically somehow maybe analyzing the figure. So can we generate a summary out of those descriptions? And this is basically called a figurative summarization, where the input is the whole text and also image, and our target is to basically generate a summary for the particular image. So basically, this is called the figurative summarization. Then there is a concept called the web-based summarization. So if you are summarizing a set of web pages, So you are searching with the in the Google with the word Taj Mahal, you are getting many web snippets. So all these web snippets are referring to Taj Mahal, or they are basically mentioning about the Taj Mahal. If we can generate a summary of all these web snippets, then this is called the web-based summarization. Then suppose if you are summarizing the emails, a particular company receives many emails, and it's very difficult for the company or the CEO or the customer care representative to go through all the emails. So can we somehow generate a summary of the emails? This is called the email-based summarization. Then there is a concept called the personalized summarization. So it's like maybe a particular user is interested in a particular information only. That when we are summarizing, if we can also focus on the user's need. So for example, that for the disaster, if there is a disaster, if we are focusing on the rescue team, then the rescue team is mostly interested in the rescue operation. So for them, the most important thing is that exact location of the disaster situation or disaster location, and also how many people are stuck or how to plan for the rescue operations. So if we are also focusing on the person, like while we are generating a summary, if we are also putting more emphasis or putting more attention to the information which is specific to a user's need, each user is having its own characteristics of the user, a particular specific need. So if we are putting focus on the attention on those information more, then this is called the personalized summarization. Then there is a concept called the sentiment-based summarization. So suppose there is a product or there is a movie. So basically, suppose users are expressing their opinions regarding a particular product. So now, if we can generate a summary of all those opinions, then this is basically called the sentiment-based summarization. So suppose a new product or a new electronic product has launched in the market, and now people are writing their reviews. So in the reviews, there are many aspects will be mentioned. So maybe some aspects user are basically very much positive about, and for some aspects users are basically complaining. So if we can also generate a summary, and it can be also in the aspect based. So like we can focus on a particular aspect, and then we can generate the summaries, or we can generate a summary of all the reviews written by the users. So this is basically called the sentiment-based summarization. Then we can also have the microblock summarization, which I already mentioned to you earlier, that this is very much popular during the disaster situations, where people are, here that in documents are basically nothing but the tweets. So tweets are collected from the Twitter, and then on a particular event, and then if we are generating a summary of all those tweets which refer to a particular event, then this is called the microblock summarization. So now these summarization systems can be either supervised or unsupervised. So, either we can use supervised or unsupervised. Now you are familiar about. So in case of supervised systems, we will be using some, training data. So for example, for this microblock summarization, if you are working with the supervised setting, then we are expecting that we have the original set of tweets, and we also have the summary available. So when we will be developing our system, we'll be using this training data. And there we can also utilize some unsupervised based approaches. I will today discuss about some unsupervised based approaches only, where we are mostly applying the clustering concept. So the idea is that if two sentences are semantically similar, suppose there are two or multiple tweets which convey the same information, then those tweets will basically form a particular cluster. So if multiple tweets are semantically similar, if they convey the same information, then they will form a particular cluster. So basically we need to apply clustering on the tweets, and then we will be generating some clusters. And then from each cluster, we have to select some important tweets to generate the summary. So this is called the microblock summarization. So now there are different quality measures for summarization. So for example, we can have the diversity. So we need to basically maximize the diversity. Now you understand in the summary, in general, summary is very much limited in length. So we cannot have a very long summary or very large summary. So in summary, in general, there is a minimum and the maximum length. So number of words in the summary is always restricted. So that's why we cannot accommodate multiple sentences in the summary. So we have only, if suppose two sentences are semantically similar or they are conveying the same information, then we cannot keep both the sentences in the summary. So in the summary, we need to keep only those sentences which are diversified in nature. So they should not very much semantically similar. So basically diversity has to be maximized in case of summarization system. Second is the position of the sentence in the document. So, if you read any news document, you will see that initial sentences are very important. And initially, in the initial sentences, reporter used to mention about the event. And the latter sentences are not very much important. Maybe in the latter sentences, reporters used to analyze the event, reporters used to write about the opinions, etc., reviews, opinions about the of himself or herself regarding the particular event. So the initial sentences are always important in any news document because they are basically providing us a kind of a summary. So the position of the sentence in a document we have to basically maximize. Third objective is the length of the sentence. We want to we prefer long sentences compared to the shorter size sentences. So long sentences are more information rich compared to the short sentences. So the length of the sentence has to be basically maximized. Then another objective function is the coverage. So in the summary, you have to select those sentences which can easily cover the entire theme of the document. So you know that there is the document is having a particular theme, and that theme should be covered in the summary. So basically the information should be somehow covered in the summary. So the coverage has to be basically maximized. Then cohesion. So cohesion is very important, that basically sentences should be coherent. Otherwise, what will happen if the sentences are completely disjoint, then you will lose the readability. So, when we'll be reading the summary summary should also be readable. So that's why, somehow the sentences should be somehow, in some way, those should be also connected to each other. So the cohesion has to be also maximized. And then the sentence similarity with the title, because title itself, when the news reporters are writing the title, it is a kind of a summary only. So title gives us a idea about the particular event which has basically happened. So if suppose the sentence is very much similar to the title, that means this sentence is information rich. So these are the few objective functions. So as I mentioned, if we are working with the extractive summarization system, so extractive summarization is nothing but a subset selection problem. So we have the original set of sentences, and now we have to select a subset of sentences to generate the summary. And this extractive summarization is basically, in the process, we are optimizing these multiple objective functions. So there are multiple possible objective functions, and we have to simultaneously optimize them. And that's why this is very much similar to multi-objective optimization, because you can see that some objective functions are also conflicting in nature. For example, if you want to increase the diversity, then readability will be compromised. So if you are only keeping the diverse sentences in the summary, then obviously the readability will be compromised. Or if you want, so basically, some of these objective functions are basically, conflicting in nature. That's why multi-objective optimization is basically a good approach of solving the extractive summarization problem. So so basically these are some other types of summarization techniques which we already many of them we have already discussed. So I will discuss with you briefly one existing technique. So how basically we can formulate this summarization problem as a clustering problem, and then how can we apply some recently developed multi-objective optimization based clustering technique to solve these problems. I will show you with one example. Okay, so I will just discuss with a recent work where this extractive summarization problem is basically formulated as a clustering problem, and then some recently developed multi-objective optimization based clustering techniques are applied for solving this clustering problem. So yeah, so basically, you know that if you see the existing extractive summarization systems, you will see that they have some drawbacks. Main drawback is that here what we are doing is that we are clustering the sentences. So the idea is that if the sentences are semantically similar, then they should form a single cluster. And then basically first we have to apply clustering in the semantic space. We have to generate clusters of the sentences, and then from each cluster we have to select the important sentences to generate the summary. So now there are many problems. One is that how to automatically detect the number of clusters. So if we are applying the clustering of the sentences, how to automatically detect the number of clusters? Then you know that none of the existing extractive summarization techniques captures the semantic similarity. So there are many such works. Here we did the thorough literature survey, and we found out that in existing literature also, in researchers have basically formulated this extractive summarization problem as a clustering problem, and they're also applying clustering in the sentence level. But how to automatically determine the appropriate number of clusters, or how to decide about the similarity between two clusters? So these are some, these are the drawbacks of the existing systems. Then low convergence rate and the loose score. So basically, the existing summarization systems suffer from the low convergence rate and the loose score, and mostly they are optimal. They are basically formulating the summarization as a single objective optimization problem. So what are the solutions to the drawback? So there are some solutions. So solution is that we can formulate this problem as a multi-object optimization problem. So we can apply some multi-object optimization based clustering technique to cluster the sentences. Okay, and the advantage of multi-object optimization based clustering is that you do not have to specify the number of clusters manually. Like k-means, k-medoid, hierarchical k-means, k-medoid, these are some popularly used partitional approaches. So these are the partitional clustering approaches where a number of clusters has to be given as an input. So users have to specify the number of clusters. But it's very difficult, no? Because here, in case of summarization, you are having sentence vectors, and the sentence vectors are higher dimensional in nature, and it's very difficult to visualize the clusters in the higher dimensions. And if we can't visualize the clusters, we cannot select the number of clusters manually. So number of clusters is a parameter, and you have to somehow automatically determine this value. So the multi-objective clustering techniques can help us in determining this number of clusters automatically. And this is one advantage of applying the multi-objective clustering technique. And if we are applying the multi-objective optimization technique, then we can simultaneously optimize multiple objective functions. I have already discussed about that there are many objective functions in case of summarization systems, and many of these are conflicting to each other. And rather than relying on a single objective function, we should simultaneously optimize multiple objective functions so that we can easily improve the quality of the clusters. So yeah, so basically this is the our proposed approach. So first we want to apply clustering in the sentence level. We want to group the cluster sentences into multiple clusters so that we can generate some semantically similar clusters, and then we can rank the clusters, and then from each cluster we can extract the important sentences. Basically, once we rank the clusters, now a cluster contains multiple sentences, and then we can basically assign some ranking to the individual sentences in a cluster as well. And we can select some top ranked sentences from each cluster, and that way we can generate the summary. So this is basically the overall procedure, that first you generate the sentence clusters, and then you assign some ranking amongst the clusters. Suppose if you are generating 10 clusters, you have to generate a ranking amongst these 10 clusters. And then now each cluster contains multiple sentences. Now, how to select some important sentences from each cluster? For that, we need to assign some ranking to the individual sentence in the cluster. We are using some sentence scoring features, and based on these sentence scoring features, we can assign some ranking to a particular sentence in a cluster. And then this way, basically, we can select some important sentences from these multiple clusters, and that will give us the summary. So now, as I mentioned, that we are using a multi-object optimization-based clustering technique, where we are simultaneously optimizing multiple cluster validity indices. So, cluster validity indices are very much similar to, the classification metrics. In classification, we have the metrics like accuracy, precision, recall, etc. So this accuracy, precision, recall, measure, these metrics help us in identifying the in measuring the quality of the clusters. So basically here also, now there are some cluster validity indices, and by using this cluster validity indices, we can check the quality of the clusters. So you can see that this is our word mover distance. So we are using this distance for computing the similarity between two sentences. So basically, word mover distance is a semantic similarity measure. So it measures the semantic similarity between two sentences. For example, it basically makes use of the word embeddings, and it is defined as the amount of distance that the embedded words of one text needs to travel to reach the embedded words of another text. For example, suppose there are two sentences. Obama speaks to the media in Illinois, and the president greets the press in Chicago. First, we need to map. So Obama is very much similar to president. So Obama will be mapped to president. Speaks will be mapped to greet. Chicago will be mapped to Illinois, and the media will be mapped to press. Okay, and now we have to find out the distance. Distance between Obama and president, distance between greet and speaks, distance between media and press, distance between Illinois and Chicago. And the summation of all these distances is the word mover distance between these two sentences. So if the two sentences are completely similar, then the word mover distance will be equal to 0. So now over here, basically, we have applied a multi-object optimization based clustering technique to cluster the set of sentences. So basically, for solving this multi-objective clustering problem, we have used the evolutionary algorithms. So these evolutionary algorithms are some nature-inspired optimization techniques. So you know that evolutionary algorithms basically follow the natural evolution process. So they are very popularly used for solving some optimization problems. So these evolutionary algorithms are inspired by the biological phenomena. Here a solution is called the individual. The representation of a solution is called the chromosome. The components of a solution are called the genes. And the set of all the chromosomes or the set of all the individuals is called the population. And basically, the survival of the fittest is called the Darwin's theory. And when suppose we have two individuals, and we are generating a new individual. So suppose we have a set of a population is consisting of a set of individuals, and now we want to generate some new individuals, and these new individuals will be generated by some genetic operators, which are crossover, mutation, and the selection. So by using these three operators, mutation, crossover, and selection, we are generating some new individuals. So, this is our evolutionary algorithms. So this is very much similar. This is called the genetic algorithm mostly. It is a very popularly used optimization technique and very old optimization technique as well. So here initially population is consisting of many individuals. So many individuals means different possible solutions of a particular optimization problem. So now we are computing the fitness values of these individual solutions. And then we are checking whether the maximum generation has reached or not. If the maximum generation has not yet reached, then we are applying the genetic operators and we are generating new solutions. And now we are checking the fitness or the objective functional values of the new solutions. And then we are updating the population. So here there is basically a loop. And at the end of the loop, when we reach the maximum number of generations, we are getting a set of parallel solutions. So here in the process, we have utilized the differential evolution as the evolutionary algorithms. Okay, so differential evolution is a evolutionary algorithms where we have to select from the population a target vector. We have to randomly select two population members. Then we have to build the weighted difference vector. Then we have to add a third randomly chosen vector with this weighted difference. We have to apply crossover with the target vector to get the trial vector, and then the smaller cost value survives into the next generation. So this is the evolution, differential evolution, and this is our problem statement. So basically, we have some set of sentences. You can see, suppose S1, S2, Sk are the set of unique sentences of a particular document. So our first task is to apply clustering on this set of sentences. And here we are using the crisp clustering, not a fuzzy clustering. So a particular sentence can be a part of a single cluster only. So we are generating disjoint clusters. And then basically this is the thing that we are generating disjoint clusters. So SI is a particular cluster consisting of some set of sentences. And now these are the union of all the clusters is equal to number of sentences, and the intersection is equal to phi. And in order to generate this clustering, we are simultaneously optimizing some cluster validity indices. So these cluster validity indices are some cluster quality measures. And these quality measures basically they check the quality of the clusters. So quality of the clusters means basically we want to make the clusters compact. Like if you see, quality means what? That suppose there are multiple sentences in a particular cluster, so those sentences should be semantically similar. So the similarity of sentences which are in a particular cluster should be high, and the sentences which are if there are two clusters, then these two clusters should be well separated. So basically we need to maximize the compactness and we have to minimize the separation. So we have to maximize the separation and we also have to maximize the compactness. So these are the criteria for a good clustering, and the cluster quality measures used to measure this. So their objective is to maximize the separation, and also basically the maximize the compactness, and they used to measure this. And if a partitioning is good with respect to these two criteria, then we can say that this is a very good partitioning. So here we have used different optimization frameworks for optimizing multiple cluster quality measures. We can utilize different meta-heuristic approaches. Differential evolution is one meta-heuristic approach. Then water cycle algorithm or the gray wolf optimizer. These are some other optimization techniques. So what we have done is that we have simultaneously optimized these objective function. We have simultaneously optimized multiple cluster quality measures by using these optimization frameworks. So what are the key points of our proposed approach? One is that now we are doing everything in the semantic space. So we are representing the sentence by using the vector representations. We are using the sentence BART, and then that way we are representing the sentences. We are determining the similarity between two sentences by using basically, the word mover distance. So word mover distance is used to find out the similarity or the dissimilarity between two sentences. We are applying the multi-object optimization-based clustering technique to cluster the set of sentences into different clusters. And in the process, we are optimizing multiple cluster validity indices. And our multi-object optimization-based clustering technique is capable of determining the number of clusters automatically. Users do not have to set the number of clusters, but it will be automatically decided by the algorithm. And so this is our overall framework. We have suppose this is single document summarization. So we have a single document. First, we are extracting all the unique sentences from the document. We are applying some pre-processing, and then we are generating the sentence vectors, and then we are initializing the population. So population contains some, each solution is basically a way of clustering the set of sentences. So how to apply clustering on the set of sentences? That is basically a solution. So a solution contains some cluster centers. So those are the sentence centers, cluster centers basically. There's some sentences which can be considered as the cluster centers. So we are initializing the population, And then, we are checking whether the generation has reached maximum number of generations or not. Then there is a concept called the self-organizing map. So, self-organizing map is a unsupervised neural network. So self-organizing map helps us in basically projecting the high dimensional data in a lower dimensional space. So that that if suppose some points are points are very much similar in nature, they will be mapped to the nearby neurons. So basically, this self-organizing map can be used as a clustering tool. Also, can be used as a feature selection tool. So self-organizing map is used here to find out the matching pool, to find out which solutions are somehow similar in nature. So basically, by using the self-organizing map, we are finding out the matching pool. And then once the matching pool is identified, we are applying the genetic operators like crossover and mutation to generate the new population P dash. Finally, we are merging P and P dash together, and then we are updating the self-organizing map training data. So there is a loop, and this loop is executed for maximum number of generations. So this is our chromosome representation. So each chromosome contains some, sentence centers. So each sentence is basically represented by a multidimensional representation. So these are the centers of the sentence centers, and each sentence is basically is having a vector representation. So now the number of clusters vary in a range 1 to n. N is the number of sentences. So at a time, we are randomly deciding a value between 1 to n, and those many centers are encoded in a particular chromosome. And this way, basically, we are in the population, there are multiple chromosomes having different number of cluster centers. And so, and there are two objective functions, PBM index and Zabini index, and each chromosome is associated with these two indices, and we are simultaneously optimizing these two indices to basically find out the best set of chromosomes. And the chromosomes represent the cluster centers. So if we can find out the best set of chromosomes, we'll be also able to find out the optimal partitionings. So there are different genetic operators. So that matching pool is constructed after considering the neighborhood solutions. This is the self-organizing map. Suppose H is the current solution, and this is the neighborhood. So this neighborhood contains some solutions. So the neighborhood of this neighborhood can be easily identified by using the matching pool. So matching pool is constructed after considering neighborhood solutions of the current solution retrieved using self-organizing map. Only neighboring solutions can match to generate the new solutions. So we can select the neighboring solutions from this particular matching pool, and then accordingly we can apply the genetic operators. So there are different operators, crossover and the mutation. So crossover is this one, xi current plus f into xi1 minus xi2. So these are some solutions for the population. Xi current is the current solution. xi1 and xi2 are randomly selected solutions for the population. And by using this equation, we are applying the crossover operation. Basically, we are generating some new solution, which is a combination of these three solutions, xi current, xi1 and xi2. So xi1 and xi2 are randomly selected solutions from the population, and xi current is the current solution. So basically, we are applying this way we are basically generating some new solutions. So if suppose the generated solution is outside the range, then we are applying, we are somehow putting this inside the range. So if xi dash is either less than the lower limit or greater than the upper limit, then basically we are somehow repairing. So this is the crossover operation. In case of mutation, we are applying different types of mutations. So a solution contains cluster centers. So now either we are changing some of the cluster centers. So cluster centers means a sentence. So suppose a cluster is basically a cluster center is basically a sentence. So either we can simply change the sentence, or we can also apply, there are two other types of mutation operations, insert and deletion. So we can also think of increasing the number of clusters. So initially there are 3 clusters, now there are 4 clusters. Or you can also apply the delete mutation. Initially there are 3 clusters. Now we have deleted 1 cluster, and now there are only 2 clusters. So these are the different types of mutations. Either we can change the existing cluster center by another sentence, or we can increase the number of clusters in a solution, or we can decrease the number of clusters in a solution. So any of these mutation type is selected randomly. Then we also have the selection operation. So originally suppose you have the n number of solutions in the whole population, and now by applying the crossover and the mutation operation, we are creating another n number of solutions. So this old n and the new n are combined together, and then we are applying the non-dominator sorting and the crowding distance. So basically you can see that we are non-dominator sorting means we are basically we are somehow we are generating all these paratoptimal surfaces. So if you can see that if suppose in your new population we have solutions A, B, C, D, E, F, then non-dominator sorting basically ranks the solutions into different paratoptimal surfaces. For example, if there are 2 objective functions f1 and f2 which are of maximization in nature, then solution A and B are the best ones, and they are not non-dominated to each other, and they also dominate all the other solutions. So this A and B basically constitutes the paratoptimal surface 1, or they are the rank 1 solutions. Now C and D, these 2 are non-dominated to each other, but they are dominated by A or B. So the C and D basically constitute the paratoptimal surface 2, or the rank 2 set of solutions. Now E and F, these are not good solutions. These 2 solutions are dominated by AB and the CD, and E and F basically constitutes a paratoptimal surface 3, or the rank 3 solutions. So basically this is called the selection operation. We are first applying the non-dominator sorting and the crowding distance. So by non-dominator sorting, we are basically generating these rank solutions, and the crowding distance means to determine whether the solution is what is the distance of a particular solution from the neighborhood. Okay, so suppose if the solution is so if the distance of a particular solution from the neighborhood is very high, then the crowding distance would be high. Otherwise, if suppose the solution is in a dense region, then the crowding distance will be low. So yes, so these are the different operators which are applied crossover mutation in the selection. So basically our target, basically why selection is required, because initially suppose we have the n number of solutions. Now after the genetic operators, we are again applying another, we are getting a new set of n solutions. Now we are combining the old set of n solutions and new set of n solutions. We are getting 2n number of solutions. And now from this 2n number of solutions, we have to select top n, which are which are good solutions. For that, this crowding distance and the ranking non-dominator sorting is basically applied. So we start with the rank 1 solutions, and then we select all the solutions on the rank 1. Then suppose if there are more space available, then we go to rank 2. And now suppose if suppose we are not able to accommodate all the solutions in rank 2, in that case we have to sort the solutions in rank 2 by using the crowding distance operator. So by using the crowding distance operator, we are putting more priority to those solutions whose crowding distance is the crowding distances is higher compared to the other solutions. So whenever suppose if we are not able to accommodate all the solutions on a particular rank, then in order to assign some ranking ranking of solutions on a particular surface, we are using the crowding distance. So now what is the summary generation? So basically you know that by applying this multi-objective clustering technique, we'll be able to generate multiple clusters, sentence clusters. Okay, so for a solution will provide us how to cluster the sentences. So a solution contains the cluster centers. So these cluster centers are nothing but the sentence, some sentences, and these sentences are basically the centers of the sentence clusters. So yeah, so as this is a meta-heuristic optimization technique, we are dealing with a set of solutions which is called the population. So at the end, we will have multiple options. So each solution will basically provide us a way of partitioning the set of sentences. So each solution will provide us a way of partitioning the set of sentences. And now we have to select a particular way of particular way of partitioning the set of sentences. So basically one possibility is that we can calculate the root score of all the solutions, and then we can select the solution which is having the highest root score. So root score will decide. So root score is a performance metric. So if you have the actual summary, and if suppose your system is generating a predicted summary, and you have the goal summary, so this root score basically a kind of string overlap. So it basically calculates how many strings or how many phrases are overlapping between the actual summary and the obtained summary. So we have to basically maximize the root score. So as I mentioned that in the population, there are many solutions. In order to quantify the quality of the solutions, we can utilize the root scores. So now to generate the summary corresponding to a ith solution. So the ith solution has cluster centers. Now how to generate summary from this partitioning? So out from these cluster centers, we can easily get the sentence clusters. Now how to generate the summary? So for that, there are two stages involved. One is the ranking of these clusters. So suppose a solution contains 10 clusters, we need to put some ranking amongst these 10 clusters. So for that, first we are deciding about the document center. So the document is having multiple sentences. So that particular sentence will be called as the document center, whose average distance to all the other sentences is the minimum. Okay, so the document has many sentences. Now the particular sentence whose average distance to all the other sentences in the document is minimum is called the document center. And now we are basically calculating the distance from the document center to all the cluster centers. And then we are assigning a rank to the clusters, which is basically which is basically we rank the clusters in descending order based on this ZK scores. And ZK is nothing but the word over distance between the document center and the cluster center. So we are computing the ZK scores for all the clusters, where that CK is the cluster center and SM is the document center. And then we rank the clusters in descending order based on these ZK scores. Now, once suppose the clusters are ranked, a cluster contains multiple sentences. So suppose you are visiting the clusters in a rank-wise manner, and now we would like to select one important sentence from a particular cluster to be added in the summary. Okay, so now how to select an important sentence from the particular cluster? For that, we are using some sentence coding features. So a particular sentence in a particular cluster is assigned a score, which is a combination of multiple factors. So one is the length of the sentences. So we have to basically, our aim is to maximize the length. The assumption behind this is that if the length is high, then basically the information richness will also be high. The second is the position of the sentence in the document. So the initial sentences are better compared to the latter sentences. So the position of the sentence really matters. So you have to maximize the position of the sentence. Third is the similarity with the title. So you have to basically maximize the similarity with the title. And fourth is the anti-redundancy. So the sentences should not convey the similar information. So this way we are assigning some sentence scores to each sentence, which is a weighted average of these four factors. So alpha 1, alpha 2, F1, F2, F3, F4 are the four factors, and alpha, beta, gamma, delta are the weights. So we are computing the weighted average of these four factors, and that is a kind of a combined score given to a particular sentence. We are arranging the sentences in descending order present in a cluster according to their sentence scores, and then we are selecting the important sentences from each cluster to generate the summary. So now the task is easy. By using the multi-object optimization-based clustering technique, we generated the sentence clusters, and then by using this word over distance and by the help of the document center, we have assigned ranking to all the clusters. Now we are visiting the clusters in a rank-wise manner, and we are assigning ranking to all the sentences which are in a particular cluster. For that, we have considered these four factors, and each sentence score is a basically weighted combination of these four factors. And finally, we are selecting the sentences having the highest sentence scores. And we are visiting all the clusters, and that way we are selecting some important sentences from each cluster. And this is basically called the summary. So here, this approach is basically, we have utilized two data sets. One is called the DUC 2001, another is called the DUC 2002. So these two data sets are very popularly used text summarization technique, text summarization data sets. So in DUC 2001, there are 30 topics. In DUC 2002, there are 59 topics. Number of documents in DUC 2001 is 309. Number of documents in DUC 2002 is 567. And length of the summary is 100 and 100. So here, as I mentioned, in case of summarization, RUSE is basically used as the evaluation measure. So RUSE measures the highest overlap, highest string overlap between two sentences. So count match n-gram. So n represents the length of the n-gram. Count match n-gram is the maximum number of overlapping n-grams between reference summary and the system summary. So reference summary is the actual summary, and the system summary is a system generated summary. So we are basically calculating how many n-grams are matching. And count n-gram is the total number of n-grams in the reference summary. In our experiment, n takes the values 1 and 2 for RUSE 1 and RUSE 2 respectively. So these are our results. So we can see that we are comparing with differential evolution, Gray-Wolf optimization, and the water cycle algorithm. So there are three versions of our proposed approach. These are the extracted summarization techniques by using differential evolution, by using Gray-Wolf optimization, by using the water cycle algorithm. And these are the RUSE 2, RUSE 1 scores. And you can see our proposed approach attains better RUSE 1, RUSE 2 scores compared to the existing techniques. And these are the whole good and the bad summaries. So you can see in some cases there is a matching, but in some cases our proposed our system is not able to predict the actual summary. So so these are some parameters, and these are the parallel surfaces. So you can see that yes, indeed, we are optimizing two objective functions, PBM index and Zarbeni index. These are some cluster quality measures of the cluster validity indices. If you are simultaneously optimizing them, then we are able to get multiple solutions on the parallel curve. So this means that yes, there are multiple ways of forming the sentence clusters. There is not a unique way of forming the sentence clusters, but the sentence clusters can be formed in multiple different ways. So now I will just quickly mention about one work where in the previous work, what we have done is that we have formulated the summarization problem as a clustering problem. We applied clustering technique to cluster the sentences, and that way we are generating some semantically similar clusters. And then we ranked the clusters, and we selected some important sentences from each cluster to generate the summary. But in this case, there are multiple objective functions like, as I mentioned earlier also, sentence similarity with the title, sentence position, coverage, cohesion, readability, sentence length. So all these objective functions are simultaneously optimized. Okay, so here, what we have done is that we have formulated this as a binary optimization problem. So the length of the solution is equal to the number of sentences in the document. So if the document is having 1000 number of sentences, then length of the chromosome will be equal to 1000. And now a particular bit could be 0 or 1. So if a particular bit equal to 1, that means that particular sentence is not selected in the summary. And if the particular bit equal to if the particular bit equal to 1, that means the sentence is selected for the summary. And if it is equal to 0, that means the sentence is not selected for generating the summary. So this is a binary representation or a binary optimization problem. So basically, that now the chromosome is a binary chromosome, and it can have either zeros or ones. So zeros means that the sentences are not selected in the summary, and ones means the sentences are selected in the summary. So we have optimized several objective functions. One is called the sentence position. Now it is no longer a the clustering problem. We are deciding automatically at once whether the sentence will be selected or not selected. You know that the disadvantage is that we have to deal with long solutions, because you know if the number of sentences in the document is very high, then accordingly the length will also increase. But now there are many objective functions, and all these objective functions are simultaneously optimized. So once is the sentence position. So it basically assigns higher scores to initial sentences of this document. As the sentence position in the document increases, the value of P decreases. Second is the similarity with the title. We need to basically maximize this so that it measures the similarity with the title. Then the third objective function is the coverage. So here you can see that SI and SJ as the sentences belonging to the generated summary and the document respectively. Here doc is the document, N is the number of sentences in the document, and SIM SI SJ is the similarity between sentences SI and SJ. So this coverage measures the extent to which sentences in the summary provide useful information about the document. Then we also have to maximize the length of the sentence. So mu L is the mean length of the sentence in the summary. LSI is the length of the sentence SI. Standard deviation is the standard deviation of lengths of sentences in the summary. So it basically favors the longest sentence, but does not entirely rule out the medium length sentence. Now there is a cohesion as well. So here when the cohesion basically measures the relatedness between the sentences that make up the summary, or it recognizes whether the summary sentences are discussing about the same information or not. And finally, the readability, what is the similarity between the consecutive two sentences. So in order to improve the readability, the similarity between the two consecutive sentences has to be maximized. So here NP is the number of sentences in the predicted summary. SI and SI minus 1 are the two consecutive sentences. C measures the similarity. So we are computing the similarity between two consecutive sentences, and that way basically we are improving the readability. So this is the overall flowchart of our proposed approach. So we are starting with a single document. We are doing some pre-processing. We are extracting all the unique sentences from the input document. And now your population is nothing but the set of chromosomes. But now these chromosomes are nothing but the solution is basically a binary solution. So if the total number of sentences in the original document is having 1000 number of 1000, then the solution will be of length 1000, and a particular value of 0 indicates that the sentence is not selected in the summary, and a value of 1 indicates the sentence is selected for the summary. And you have to basically automatically decide about the appropriate combination of zeros and ones. And the objective functions are what we have just discussed. There are 6 objective functions which have to be simultaneously optimized by using the multivariate optimization concept. So finally, we are checking whether we have reached the maximum number of generations or not. And then accordingly, we are computing the SOM training data. So SOM will give us the matching pool. So which solutions are in the neighborhood of a particular solution. So SOM basically gives us the matching pool. And then from the matching pool, you are selecting some solutions. And those solutions are used for applying the genetic operators like crossover and the mutation. And we are generating some new solutions. We are merging P and P dash together, and we are selecting the best P solutions. So here, these are the two versions. So in the approach 1, we are basically optimizing this OB1 into alpha, OB2 into beta, OB3 into gamma. So if there are multiple objectives, each objective is basically assigned a weightage. So this alpha, beta, gamma, delta are the weightages, and then we are combining them with the we are multiplying them with the objective functions, and then we are optimizing them. All the objective functions values are multiplied with their respective weights and then simultaneously optimized. And here basically we are optimizing all the objective functions separately, and here we have not multiplied them by some value. Now there are different versions. Either we can go with SOM or without SOM. So SOM self-organizing map is used to generate the matching pool. Either we can have a matching pool generated by the self-organizing map, or we can discard the matching pool. We can consider the entire population as the matching pool. And then there are many different distance measures which can be utilized to find out this. Like you can see that in order to compute the objective functions, For example, similarity with the title, then the coverage or the coverage or the cohesion or the readability, we always have to compute the similarity. So this similarity can be computed by using different measures, like, either we can use the cosine distance, or we can use the normalized Google distance, or we can use the word distance. So these are the solutions. You can see that we are getting multiple solutions. So that means that indeed it is possible to indeed it is possible to basically generate multiple solutions. So given a particular document, there are multiple ways of generating the summary. So these are some results of abolition studies. Basically, well, in our approach, we have the with sum, without sum version, and also we have that different distance functions, and these are the results. And we have compared with the existing techniques, and you can see we are able to outperform the existing techniques. Yes, so basically now let me just briefly discuss about a new problem statement, which is called the the multimodal summarization. So let me just briefly discuss about this. Yeah, so what is multimodality? So that multimodality is nowadays, the multimodal processing is nowadays very common. So multimodal processing means that we have to deal with multiple sources of information. Like, for example, till now we were dealing with only the text data, but in some cases, suppose some newspapers are reporting some news events. So in that case, we can have not only the text information, but we can also have the images or the videos. So I hope I am audible, no? If there will be any issue, please let me know. You can chat, or you can, because it's in an online setup, it's very difficult to understand.
Yes, ma'am, you're audible.
Okay, thank you. Yeah, thank you. Yes, so multimodality is nowadays very popular concept, because it helps us in dealing with the multiple sources of information. As I mentioned, that suppose nowadays in news reports also, you have seen that news reporters are not only writing in text, but they are also displaying some images. Whenever they are describing some event, they're not only writing the description in text, but they are also displaying some images, so that from the images the readers can easily understand, the better users can get a better understanding of the particular event. So basically, multimodality is nowadays a very common concept, because our experience of the world is always multimodal. Because whenever we have to take a decision about a particular object, we used to collect information from multiple sources. Like, we used to see the object, we used to hear the sound or touch the object, smell, and then we are collecting information from multiple sensors, and then somehow we are combining them together, and then we are taking a decision. So multimodal learning consolidates heterogeneous data from various sensors and data inputs into a single model. So that basically this is the multimodal processing. And why multimodal summarization? Because as I mentioned, that nowadays major platforms like newspapers, social media, blog posts are all multimodal. When the tweet also, whenever we are typing, we are not only typing, but we are often uploading or posting some images in the Twitter. Or in the newspapers also, reporters are not only writing about not only writing a textual description of the event, but they are also showing some images. So basically, our multimodal data is everywhere. So can we generate a multimodal summary? And another important thing is that text and images are somehow complementary to each other. Some information cannot be represented better in text, but those can be easily represented better in images. But there are some concepts which can be better represented in image but not in text. So, for example, a concept like freedom, affection, etc., are difficult to be expressed using images. But basically, what a piano looks like, this can be easily described in image than in text. So there are multiple concepts, and there are multiple concepts, and these concepts can be that this image and the text are somehow complementary to each other. So in recent years, we are also working on this multimodal summarization, and we are publishing on a regular basis some top tier A star A conference papers on this particular topic. So let me now briefly discuss about this particular task. So this task is named as text, image, video summarization. So in the input side, we have a set of documents, text documents, we have a set of images, and we have a set of videos. And now we are generating a summary. So in the summary, we have a text summary, a image summary, and the video summary. So in the input, we have a set of text documents, a set of images, and a set of videos. And then we are in the output also, there is a text summary, which is a summary of the text documents. And there is an image summary, with this summary is a representative of the set of images in the input. And there is a single video, which is called the video summary. Now, what about the data set? So in this particular paper, this multimodal summarization for asynchronous collection of text, image, audio, and video, which got accepted in ENLP 2017, authors Juetel, they basically developed a data set. So this Juetel are the first one who introduced this particular term, multimodal summarization. So basically, they developed a new data set, and this data set was having 25 topics. Each topic is comprising of 20 text documents per topic, 3 to 9 images per topic, 3 to 8 videos per topic, 3 text references per topic. So now we are basically employing some annotators, because this data set is having in the input side there are multimodal information, but in the output side there is only text summary. So image summary and the video summary are not available. But in our case, we want to have multimodality in the input side as well as in the output side. So that's why we have basically enhanced this data set. We have manually selected some images as the image summary and also some videos as the video summary. So we have employed some human annotators, and these human annotators have manually read the summary and the documents, and then they selected some images as the image summary and a video as the video summary. So next, we basically worked on an integer linear programming based framework for solving this multimodal summarization problem. So this is our overall framework. So in the input, we have the multiple documents, we have the images, and we have the videos. From the videos, we are generating we are basically dividing into two parts: speech transcripts and also the keyframes. So the speech transcripts are further added to the text set, because the speech transcripts are nothing but the textual representations of the speech. And then we also have the keyframes. So these keyframes are basically nothing but the images. So the keyframes are also added to the images. So now finally we are dealing with only two modalities, text and the image. Now there is a concept called the integer linear programming. So this integer linear programming, basically now by applying the integer linear programming, we are generating some text summary and also the image summary. And then in the next process, it is basically a process of remote summarization. So here what we are doing, we have the text summary and the image summary. Now we are applying some post-processing technique. And as the application of the post-processing technique, we are selecting some more images in the image summary, and we are also selecting a video in the video summary. So this is our final summarization, where there is a text summary, there is an image summary, and there is a video summary. So we are initially there are some image sets. So, and from the image set, we are adding some more images in the image summary. So this is our basic skeleton. We have used the Gurobi optimizer to perform this integer linear programming, to solve this integer linear programming optimization. So in this integer linear programming optimization, we have to define the decision variables, we have to define the objective functions, we have to define the constants. So these are the decision variables: m, I, j, text. It is a into n binary square matrix. So here indicates that diagonals basically represent the cluster centers. So if the diagonal equal to 1, that means it is the cluster centers. So then m, I, j image, here again this is the p into p binary square matrix. P is the number of images. So the entries represent 0 or 1. So basically, if it is basically either a particular element could be a center, or some other element can be a part of the particular cluster. And then we can also have the cross correlation. So this cross correlation tries to improve the similarity between the sentence cluster and the image sentence cluster and the image cluster. So this is our objective function. So we have some components like saliency and the redundancy. So you know that saliency is computed like this. So this is our overall objective function. It's an integer linear programming. So there is only one objective function, which is basically a combination of saliency of text, saliency of images, and the cross correlation between the cross correlation of the images and the text. So saliency is defined like this. These are the center, these are the points in a particular cluster of the sentences in a particular cluster, and then we are taking the summation over. And so basically this way we are computing the different objective functions and we are combining them together. So saliency basically captures the compactness of a particular cluster. And then this G item I, basically this is calculated, this contains all the sentences which are in a particular cluster, and then we are comparing the cross correlation similarity. So there are many constants, like all matrices are binary. There must be exactly k txt number of text clusters, k image number of image clusters, and then either a particular sample entity can be an exemplar or it can be a part of a single cluster. And for an entity to be endorsed by any other element, it must have been exemplar in the vector space. So now again we are applying some post processing. So in the post processing, you know that we are selecting some non keyframe images, and some of those non keyframe images are added to the image set. And other than these images, select those images who have cosine similarity between alpha beta. So in the post-processing, we are assigning some score to a particular video. From the videos, we are extracting the speech transcripts and also the keyframes. The similarity of the speech transcripts are computed with respect to the text summary, and the similarity of the keyframes are computed with respect to the image summary. And we are assigning a score of this average of visual score and the verbal score to a particular sentence. And the sentence which is having the average and the video which is having the average visual verbal score is basically selected for generating the summary. So these are some results. So basically you can see on the data set that we have developed, we are applying the proposed approach on the particular data set, and we have computed the different ruse score values. And you can see that compared to the existing systems, this proposed system attains the better ruse 2 and ruse 1 scores. These are the image results, image summary results. Here we have computed the precision and recall. So with the threshold of 3, we are getting the highest precision and recall. So in the next work, we have again applied this multi-object optimization concept for solving the multimodal summarization problem. So multi-object optimization I have already discussed about. So this is our proposed approach. So here we have that again the text document, images, and the videos. From the videos, we are extracting the speech transcripts and also the keyframes. Speech transcripts are added to the text document, and the keyframes are added to the the images. And now we have two modalities, text set and the image set. Now we are projecting them in the common space, and then for that we are basically projecting them in a common space, and then we are applying the clustering. So by using the clustering, we are somehow clustering the images and the text all together. So if the sentence and the images are somehow semantically similar, we form a single cluster out of them. So for that, we are using this meta-heuristic optimization technique, like we are using the population initialization, genetic crossover mutation operations, etc. And then we are generating some new P solutions. These P solutions and the whole P solutions are combined. And then from this combined set of solutions, we are selecting P number of base solutions. So we propose a novel multi-object optimization based differential evolution technique. So differential evolution is utilized as an optimization technique and to solve this particular problem. And here, there, that part we can easily see that we are applying the clustering based approaches. So each solution of the string contains many cluster centers, very much similar to our previous work. So here also the solutions of the string contains the cluster centers. So here we are using the different crossover operations crossover, mutation, etc. operations. And as a result, we are generating some new solutions. Finally, the new solutions and the old solutions are combined. We apply the non-dominant sorting and the crowding distance to select best number of P solutions from the population. And this best number of P solutions basically are further analyzed to generate the summary. So yeah, so there are some stopping criteria. Maximum number of generations is used as a stopping criteria. After the stopping criteria is made, we proceed with post-processing the paradoxical solutions. So there are two types of frameworks. In the one framework, we are using some summarization-based objective functions like by redundancy. Saliency is nothing but the compactness. So we have to basically, we have to maximize the compactness and we have to minimize the redundancy. We also have to, in the image side also, we have to maximize the saliency, minimize the redundancy, and the cross correlation. It is a similarity between the image centers and the clusters and the text centers. So in the summarization based approach, we are using these three objective functions. In a clustering based approach, we are using the objective functions PBM index, PBM index, PBM, as I mentioned, the PBM index, PBM for text, PBM for image, and the cross correlation. So PBM is the cluster validity index. And this is the thing that salience is nothing but the similarity between all the sentences which are in a particular cluster with respect to the sentence cluster. So this XCJ mod is the sentence cluster and XI mod is any other sentence which are in a particular cluster. So this is the cosine similarity. So we have to maximize the salience. Redundancy is basically the cosine similarity between two separate cluster centers. So basically, we need to somehow reduce the redundancy, and the cross-modal correspondence has to be improved. So the post-processing is very much similar to our previous approach. So we apply first the clustering, and then we are adding some more images and also a video in the output summary. So our algorithm is selecting some images in the image summary, but now we are adding some more images in the image summary, and also we are selecting a video based on the visual and the verbal score, and we are selecting the particular video as the video summary. So these are the proposed, these are the comparative study. You can see that we are comparing with the different existing techniques. So these are our proposed approach, summarization based, multivariate optimization, and the clustering based. So you can see that in some of the cases, these existing systems are not performing good. And basically our proposed system outperforms all the existing systems. This is one example summary. You can see that this is the Victory Day celebration of Russia. And this is the summary that we are getting. We are summarizing 20 articles. 20 articles basically talk about the Victory Day celebration of Russia. And these are the part of the image summary. And this is a one video summary that is also selected as a part of the system. So yes, so I think I have to stop now, but I just want to introduce one concept, which is called the supplementary and the complementary enhancement. So as you know, here in the multimodal summarization, the text modality is the primary modality. So here we have considered that the text modality is our primary modality, and the image modality is our auxiliary modality. So now we can define two concepts called the supplementary enhancement and the complementary enhancement. So the supplementary enhancement is that suppose we are generating a text summary, and now there are some images in the image summary. If the information content of the images and the text are not same, like whatever is written in the text summary is not present in the image summary, then this is called basically this is an example of basically the complementary enhancement, that the information content of the images are different from the information content of the text summary. For example, here you can see here the summary is talking about the Russian airline accident, and the Russian airliner which crashed in the Sinai desert, killing 2 to 4 people, was down by a bomb. So it is talking about the accident. But here in the images, something is shown which is not written in the text. So this is an example of a complementary enhancement. But here you can see these images contain some information, but that information is already present in the text summary. So this is an example of the supplementary enhancement. So these two, we have also introduced these two concepts. And then we have developed some multi-object optimization based approach for identifying the supplementary and the complementary enhancement summaries. Yes, so yeah, so maybe I think I am out of time now, no? My timing was up to 3:30. Hello?
Hello?
Yes.
Yeah, the session should be end at 3:30.
Yeah. Sorry, I'm just 1 minute late. Yes.
It's okay.
Yeah, I think there are some questions by Sanjana. Most of the meta-heuristic algorithms are biological genetic algorithms such as ant colony optimization, swarm optimization, dragonfly algorithm belong to NP hard or NP complete class of problems. Then what forms the basis for selecting a particular algorithm solving? Yeah. Sanjana, you are very much correct. So basically, these are all kind of, these are very popular. They're like genetic algorithm, ant colony, swarm optimization. These are all very popular meta-heuristic algorithms. So as I mentioned that we have used the differential evolution here, but we also compared our differential evolution with the genetic algorithm, water cycle algorithm, and the ant colony optimization, etc. So we have basically compared the performance of our approach with other approaches as well, but you can select any because here our main focus is not to develop a new algorithm or new meta-heuristic optimization technique. We really just want to apply this, use this meta-heuristic optimization technique for optimizing the multiple objective functions. Sanjana, is it okay?
Yes, ma'am.
Ma'am, yes, please.
Ma'am, then how we can
Yeah, Sanjana.
Hello, ma'am.
Yeah.
Ma'am, then how will we be able to describe which result is better?
Okay.
If we are using different, just say if we are using ant optimization, ant colony optimization or swarm optimization. Then ma'am, how will define which will result better?
Okay, so yeah, so it's very difficult to understand. Okay, mostly this differential evolution or the ant colony optimization techniques are very popularly used because genetic algorithm is a very old one now, and differential evolution and colony, these are the new meta-heuristic techniques. But here we generally used to measure the ruse score. Like as I mentioned, that ruse is the performance measure for the summarization technique. So we applied these various techniques. We are generating the summary, and then we are computing the ruse score. Okay, and we are comparing the performance of these different approaches with respect to the ruse. But yeah, it's a very difficult problem, like which one to be selected. Like as we have this large collection of meta-heuristic optimization techniques, which one to be selected? So I think you can go for differential evolution or the ANCOL or whichever, because here our task is not very complex. Our task is very simple, that we have to select the important sentences. So we have a set of, it's a subset selection problem. So we have a large collection of sentences, and we have to simultaneously optimize multiple objective functions. And as in the process, we have to select the important sentences. So yes, but here we have used the ruse as a performance measure. So we are applying the differential evolution, genetic algorithm, and colony optimization for solving this clustering problem, sentence clustering problem. We are basically getting multiple sentence clusters. And then for each solution, we are generating the summary. And finally, we are evaluating the summary with respect to the ruse. And the beta-heuristic algorithm, which is giving us the highest ruse, we are selecting this as the optimal one.
Okay, ma'am. Then means we have to check for the different techniques available. Then we can.
Yeah. You need to do an ablation study. Yes. You need to do an evolution study, but my personal experience is that maybe the differential evolution is nowadays giving better result. Also, maybe you can go for, if you have such kind of optimization algorithms, optimization problems, maybe you can think of applying differential evolution. It's a standard approach, and it often outperforms the other existing meta-heuristic approaches.
Okay, ma'am. Thank you, ma'am.
Yeah, any other question? Students, if you have any question, you can ask me.
Hello. Thank
Hi.
you, ma'am. I don't think there is any questions from audience.
Okay. Thank you. Thanks a lot. So
Thank
we'll
you,
meet
ma'am.
tomorrow. Yeah, and tomorrow session, I'll be discussing about the chatbots or the dialogue systems, which is another important task of natural language processing. So we'll discuss about some how we can apply deep learning, machine learning techniques, and the reinforcement learning algorithms for developing a chatbot. You know that chatbot is, you must have seen the Alexa or the Siri. So how can we build our own chatbot by applying this in natural language processing or the deep learning, machine learning techniques that we will discuss in tomorrow's lecture. Okay. Yeah. So thank you. Thank you for this session. So yeah, we will meet tomorrow.
Thank
Bye.
you, ma'am.